Statistical measurement in nursing research is important as we proceed into analyzing and interpreting data. As we discussed how we measure variables, this time let us see how we can use statistics to make sense of those measurements, summarize findings, and draw valid conclusions that will eventually guide our nursing practice. Statistical measurement refers to the use of statistical tools to analyze and summarize research data. Think of statistics as our language for understanding numbers. It helps us describe what the data mean and what patterns exist. It also involves data conversion. This is turning raw data, those numbers that we got from our surveys, tests, or observations, turning them into meaningful information. For example, if we gathered 100 blood pressure readings, statistical tools will help us summarize these readings into averages or to identify trends. Statistical measurement also serves as a foundation for drawing valid research conclusions. Without statistics, data remain just numbers, but with statistics, they become evidences. Statistical measurement ensures objectivity and precision in interpretation. This means our conclusions are not based on personal judgment, but on measurable evidence. It also helps identify patterns, relationships, and trends. For example, linking lifestyle to hypertension or stress level to academic performance. There are two major types of statistics. We have descriptive statistics and inferential statistics. Descriptive statistics is used to help us summarize and describe data. They tell us what is happening in our data set, while inferential statistics help us draw conclusions or make generalizations from a sample to the larger population. Both types are essential. Descriptive statistics organize and present data clearly, while inferential statistics allow us to interpret what those data mean beyond our sample. Descriptive statistics are used to organize and simplify large data sets. Imagine collecting hundreds of records or answers. These descriptive tools help summarize those information clearly. They describe the characteristics of that sample or population, such as their age, weight, or satisfaction level. Descriptive statistics often use measures of central tendency and variability. These are two key concepts that show what's typical in the data and how spread it is. The measures of central tendency represents the center or the typical value in a data set. There are three of them. The mean. This is the average of all scores. It is the most common measure, but sensitive to extreme values. We have the median. This is the middle score when data are arranged in order. It is useful when data have outliers. We have the mode. This is the most frequently occurring value in the data set. For example, if most patients rated their satisfaction as 4 on a 1 to 5 scale, the mode is 4. In nursing, using the right measure helps describe patient outcomes more accurately. Aside from the center, we also want to know how spread out the data are. That is where measures of variability come in. Measures of variability show how scores differ or spread out from the average or the mean. We have the range. This is the difference between the highest and the lowest values. Simply put, this doesn't reflect the distribution, but they only show the difference between the highest and the lowest values. Then we have the variance. The variance is the average of the square deviation from the mean. It shows how much these values differ. Then we have the standard deviation. This is the average distance from the mean. This is widely used in research because it is in the same units as the data. For instance, a smaller standard deviation in patient recovery times means the outcomes are more consistent across participants. How do we visualize data? Data distribution shows how data are spread across a range of values. We have the normal distribution. This is a bell shaped symmetrical curve. Most scores fall under the mean. This is common in biological and social sciences. Then we have the skewed distribution. The data lean either to the left or to the right, meaning most values are either higher or lower than the mean. Then we have kurtosis. This describes how peaked or flat the curve is. Recognizing these shapes helps researchers choose the right statistical tests and interpret data correctly. The frequency distribution shows how often each score occurs in the dataset. Visuals make interpretation easier. The most common forms include, aside from the tables, we have the bar graphs. This is good for categorical data like gender or diagnosis. And then we have the histograms. These show continuous data such as age or blood pressure. Then we have the pie charts. These display proportions of a whole. And the frequency polygons. which connect points showing how data change across values. These tools make data interpretation accessible, especially in presentation and research posters. Let us now go to how to describe data. That is where we discuss inferential statistics, where we interpret data and make conclusion. Inferential statistics allow us to make generalizations from a sample to a population. It involves hypothesis testing, that is, checking if observed results are due to chance or a real effect. For instance, if a new nursing intervention reduces anxiety scores, inferential statistics help determine if that reduction is statistically significant. We also estimate population parameters based on sample data, like predicting the average blood pressure of Filipino adults using a sample of patients. This process depends heavily on sampling and probability. Sampling means selecting participants who represent a population. A good sample reflects the larger group accurately. Probability, on the other hand, is the likelihood that results occurred by chance. Random sampling increases validity because it ensures every member of the population has an equal chance to be included. Together, sampling and probability make statistical inferences trustworthy. Now let's look at the different common inferential tests used in research. We have the parametric test and non-parametric test, which are broad categories for inferential testing. We have parametric tests, which assume that data follow a normal distribution. These include t-tests, ANOVA, and the Pearson's R correlation. For non-parametric tests, which is used when data don't meet normality assumptions, these tests include the chi-square test and the Spearman's rho. The choice depends on the type of variable and level of measurement. Example, chi-square for normal data and chi-square for nominal data, and t-test for ratio or interval data. Now, how do we analyze relationships between variables? We have the bivariate analysis, which examines the relationship between two variables. Under this, we have correlation, which measures the strength and direction of relationships. Example is stress level and sleep hours. And we have the t-tests, which determines the difference between two means. And the chi-square, which checks relationships between categories, such as gender and vaccination status. These tools help us researchers identify meaningful connection that may guide our nursing practice. For studies involving more than two variables, we use multivariate analysis. Multivariate analysis examines relationships among three or more variables. Common techniques include multiple regression. This predicts an outcome based on several predictors. We have the multivariate analysis of variance, which compares multiple dependent variables. And there is factor analysis, which identifies underlying patterns among variables. In nursing, this is useful for complex problems like predicting quality of life based on specific demographics like age, health status, and social support. And what about hypothesis? How do we test hypothesis? Hypothesis testing determines whether observed differences are due to chance. The steps are stating the null and alternative hypothesis. The null would say that there is no difference or relationship between the variables, while the alternative hypothesis would say that there is a difference, a significant difference, or relationship between the variables. We also set the significance level or the alpha, usually at 5% or 0.05, and then compute the test statistics, either t-test or the t-value or chi-square value, and then compare it with the critical value from statistical tables. Then decide whether to accept or reject the null hypothesis. This process gives structure to our design and our decision making in research. What does it mean when results are statistically significant? Statistical significance means results are unlikely due to chance. It is expressed using p-values or probability values. If the p-value is lesser than 0.05, we reject the null hypothesis, meaning the result is statistically significant. The lower the p-value, the stronger the evidence against the null. However, remember that statistical significance doesn't always mean clinical importance. We nurses must interpret results in context. Another important concept to understand is effect size and power. Effect size measures the magnitude of a relationship or the difference. It tells us how meaningful the result is, not just whether it exists. The power refers to the ability of a test to detect a true effect when it exists. Larger sample sizes increase power, reducing the risk of missing true relationships in data. There are two types of errors that we might encounter in hypothesis testing. There is a type 1 error or the alpha error, which is rejecting a true null hypothesis. In short, it is a false positive. The type 2 error or the beta error, failing to reject a false null hypothesis, or what we call the false negative. Balancing alpha and beta helps ensure valid conclusions. We researchers typically minimize both by careful sampling, proper test selection, and adequate power. We also use confidence intervals to provide more context to statistical findings. Confidence intervals provide a range within which the population value likely falls. For example, if the average BMI is 24 with a 95% confidence interval of 23 to 25, we can be 95% confident that the true population BMI is between those values. This adds practical meaning to significance testing, helping us interpret how results apply in real life. Once the data are analyzed, we report and interpret results clearly. In reporting and interpreting results, we report both statistical and clinical significance to show scientific accuracy and real world value. We use tables, charts, and graphs for clarity. We include measures of central tendency, variability, and p values to make results transparent. In our nursing practice, clear communication of statistical results ensures that evidence can be applied effectively in clinical settings. To summarize, we discussed that statistical measurement turns raw data into meaningful evidence. Descriptive statistics organize data, while inferential statistics draw conclusion. By understanding sampling, probability, and hypothesis testing, we ensure sound research interpretation. And finally, interpreting both statistical and clinical significance bridges research and nursing practice. Statistics empower us to transform data into action, helping us make informed, evidence based decisions that improve patient outcomes.